Legal Semantic Search App. This is an example application to demonstrate how semantic search works using the Pinecone database and voyageAI. The app we present here is a basic tool designed for searching legal cases. It not only allows you to search through cases but can be used to find any content that has been indexed in the Pinecone database. Now let's conduct a search for case involving US President. This search will scan through the vector embeddings of the document we have ingested in Pinecone, retrieve relevant results, and return list of cases involving US President. This is impressive and has numerous practical applications such as helping law students find cases quickly and efficiently. We will learn how to build this app from scratch. Whether you are a beginner or already familiar with Pinecone and want to create practical applications, this guide is for you. So what exactly is Pinecone? Pinecone is a specialized database designed to work with vectors, which are numerical representation of data, often generated by AI models. In simple terms, it helps store and quickly search through these vectors. This is especially useful for applications like recommendation systems, semantic search, and natural language processing, where you need to find similar items or information based on the relationship between data points. So below here is the workflow of how Pinecone database works. So I'll move to erase.io and have a practical walkthrough on how these steps can be embedded into our application. So let's start with the first step, which is embed data. Over here. So let's say we have this document here. This document named constitutional right. So a case. So for this project, it's a legal semantic search. So we have a case named constitutional right. Constitutional right. Right. So what the embedding does is to convert this document into a vector form, which is the numerical representation of the content. So the vector form could be something like this. So we have an array of arrays, just plain numbers, 7, 8, in that order. Okay, so we have numerous arrays all the way to the number of documents. Okay, so this is what we call the vector embeddings. And the next step is to create an index. So the index is to store your vector embeddings, specify the dimensions and similarity metrics of the embedded model you used. So the step 2 talks about something like this, right? So the step 2 is just, adding a dimension to the vector. So the dimension could be something like 1, 5, 3, 6, which we are going to, learn more about when we start writing the code for this project. So create an index, right? Create the index for the model output vector of dimensions 1, 5, 6. And also have a metric. So we are going to talk about numerous metrics that we can have in Pinecone. So like the cosine and the rest. So you create the vector embedding, step 1. Then you move to creating the index with a dimension. And then in step 3, we ingest the data. So ingesting the data basically means loading your vector embeddings and related metadata. So for example, the document we have is case A. Case A, which is the constitutional right case. So the ingest data is going to have the title, okay, as a metadata named case A as the constitutional right for the title, and more documents as we may find here. When we move to the code, we can see we have all these documents here. So we're going to create metadata. The file name is a metadata, the title, the defendant, the date, the topic, and the outcome. So all these are going to be the metadata we are going to ingest into the Pinecone database. Okay. And the fourth step, right after we are done ingesting the database, is going to be the search. So the fourth step is going to be the search. And we all know what the search is. The search is all about retrieving, whatever we've stored inside the Pinecone database. So more of this, the practical usage on how these steps works will be demonstrated when we start writing the code. So you don't have to worry much about that. So you have the search, and the final stage is optimize performance. So we can optimize the performance to filter queries using the metadata to narrow down the results and ensure the search is more relevant. So this is the basic steps on how Pinecone works, and we are going to create this in the application. And the next tool we are going to use is voyageAI, which is basically going to provide for us a cutting-edge vector embedding and re-ranking capabilities. For this project, I have prepared a starter file to make everything easier for you. This starter file includes the document, images, and the necessary packages for building this app. Simply clone the project, open your favorite code editor, and ensure you have all these files available in the project directory. So the docs, the image, the app, the src folder, the app folder with the types and utils folder inside the app folder, components, and the lib folder. So make sure you have all these available in your project directory. So if you have all the modules installed, you should be able to run npm run dev to launch the application. So we have the app starting on localhost port 3001. Move back to my browser, search for localhost port 3001. So you should be able to see this div with this test and the spinner over here. Back to the code. So let me show you how the bigger picture of this application is going to work. So when we fire the application on localhost port 3001 or localhost port 3000, these are the steps that take place in the application. So we have the first step to be the bootstrapping phase. So we have the bootstrapping phase. And what this bootstrapping does is to check if you have an index. Remember when I was explaining how Pinecone works, we first embed the data and create an index, ingest it, and then, make queries to the vector embeddings, right? So this bootstrapping is going to check if you have an index existing in the Pinecone database. If that is the case, we just, load the data into the application and prepare it for search. And if there is no index existing in our Pinecone database, we go through the steps, embed the data, convert the data into the vector embeddings, create an index, and ingest the data into the Pinecone database, right? So that's what the bootstrapping is doing here. So we check for index. So we check for index. If index exists, if the index exists, we just, prepare the application for searching through the document. Else, meaning we don't have any index. So if you don't have any index, we go through the process of creating. So we first create, embed the data, right? So we go through all these steps all over again. Embed the data, embed data, create index, create index, 3, ingest data, 4, we prepare it for search, and 5, we optimize. So this is the the steps that we are going to go through if you don't have any index inside the Pinecone database, right? So we are going to create APIs for the bootstrap, ingest, and search. Let's move back to our code. And inside the app directory, we are going to create a new folder named API, right? So inside this API folder, we are going to create 3 folders. So we have the bootstrap, we are going to have the ingest. We are going to have the search. And each of them, we are going to create the route.txt, the normal convention for creating APIs in Next.js. And we have route.txt. And for the search, we are also going to have route.txt. So let's start with the bootstrap, because that's where the application is going to start. So inside this bootstrap API, we are going to import Nest response. Import Nest response from Nest server. So this is going to be a post request. So we are going to have export async, function post. And within this post request, we are going to initiate the bootstrapping. So initiate bootstrapping. And then we return the next response. So let's start with the initiating of bootstrapping. So we await this an async function, initiate bootstrapping. So we don't have this bootstrapping function created yet. So let's go ahead and create this function. Inside the app directory, we are going to create a new folder named services. And this services is going to have two files. So let's start with the bootstrap.txt. And the next one is going to be pineconeDB.ts, which I'm going to explain the use of this file in these tutorials later on. So we have the bootstrap.typescript. Let's start writing the code for this. And then we move back here to complete whatever you want to do here. All right, so over here, let's create the initiate bootstrapping function. So we have export const initiate bootstrapping, which is going to be an async function. Provide the target index as an argument. Okay, so I'm going to explain why we need the index in a second. So let's create a base URL. So this base URL is going to tell the application where to locate the APIs. So whether we are in localhost or in production, the app should be able to bootstrap the data without any problem. So we have process.env. We are going to create this in a second. Process.env vessel URL, or maybe Netlify URL, or any other production URL of your choice. So let's just make this production URL. Production URL. So we check if the base URL is a production URL. We want to make the base URL this HTTPS. We have this here process.env.production URL. Else we want to have localhost. You want to have this. So after we are done creating the base URL, we are going to initiate a post request with fetch to the ingest endpoint, this endpoint over here, in order to begin the chunking, embedding, and inserting documents that will form our knowledge base. So right now, we are not even done with the bootstrap endpoint yet. So let's go ahead and create the post request over here and import, the function inside the route.ts for the bootstrap. And then go ahead and create the ingest route.ts as well. So we are going to have a constant here, response equals await fetch, and then we have the base URL here. So base URL API /ingest, comma, we bring our parentheses here, we bring our curly bracket here, and inside the curly bracket, this is going to be a post request, and we're going to have the headers, and the headers to be content type application JSON. So we have that here, and we're going to have the body. So the body is going to be the target index. The index you're going to pass in over here, which is going to come from Pinecone database. So we have JSON.stringify providing the target index, right? And if the response is not okay, we want to throw this error here that says API request failed with the status and log the error status inside our console. Right, so this is a server component. Let's have the use server over here. Beautiful. So next, we are going to import the initiate bootstrapping inside the route.ts file here. So let's import it. Initiate bootstrapping. Provide the index as an argument. So we are going to get the index from the env variable. Don't worry, we are going to create all the environment variables in a second. So we have pinecone underscore index. This is going to be a string. Okay, awesome. So right now we have our bootstrap post request created. So one more thing, let's return the next response. So we are going to have this over here returned when we have a success. So status to 200, meaning we have a successful, request. So this is the function to create the post request for the bootstrap. So when the application loads, we are going to create an endpoint which is going to trigger this bootstrapping, and this bootstrapping is also going to trigger the ingest, the ingest post request. So let's create the ingest post request. Remember, the ingest is responsible for chunking, embedding, and inserting the document that is going to form our knowledge base. So let's go ahead and create the API for ingest. So over here, we are going to have next request and next response imported from Next server, like this. And you're going to have export async function post, and the request is going to be next request. Create a constant, and we get hold of the target index. Remember, we are passing the target index as the body for this request. So we have that. We get hold of that. Await request.json. We distract it from the JSON object. So we are going to do two things over here. The first one is going to be handle bootstrapping, and return next response. So you know what? Let's return the next response here, and create the function for the handle bootstrapping. We pass in the target index. So let's create this function, right? Back to the services folder, click on the bootstrap.ts, and we are going to create the handle bootstrap function over here. The bootstrap function, so let's export constant handle bootstrapping. Going to be an async function, pass in the target index. It's a string, a type of string. All right, so over here, you're going to have the try catch block. Okay. And inside the try block, we are going to have this console.log. So we want to print to the console that we are running the bootstrapping procedure against the Pinecone index. Okay, against the Pinecone index. And then we create the index if necessary. So you're going to have this function to create an index for us if we do not have any index. So create index if necessary. All right. So we're going to have that function created. So create index if necessary. And we don't have this function yet, but it's going to accept, the target index as an argument. So let's go ahead and create this function. So let's open the Pinecone. Sorry, this is supposed to be Pinecone, not Pinecones. So let's get rid of this S here, pinecone.txt. Right. So over here, we are going to have the function named, create index if necessary. So we are going to have a spot async function. And the name of the function is going to be create index if necessary. The parameters is going to be just the index name. With the type string. And inside here, we are going to call the Pinecone. So let's initiate the Pinecone. Okay. Let's initiate Pinecone first before we can, access the create index function on the Pinecone object. So to initiate the Pinecone, we have to first import Pinecone from this module. So we have Pinecone here, Pinecone database /Pinecone. Remember, in the starter file, we have all those packages in the package.json file. So when you run npm install or yarn install, it comes along with all these packages. Right, so we have the Pinecone imported. So let's initialize it. So we have a const Pinecone, new Pinecone. And here we are going to provide an API key, which we are yet to create. So don't worry, you're going to create that in a second. So Pinecone API key. So let's go ahead and create the API key, +string. Let's go ahead and create the API key and come back here to write the rest of the code. So back to our browser, you're going to search for Pinecone API key. Click on the first link. Scroll the way down here and click on Pinecone console. API keys. So I already have one here. If you don't have an API key, just click on create API key button over here and give it a name. So the name is going to be legal semantic search API key. Legal semantic search API key. Create one. Copy the API key. Move back to the application, and inside the .env.example file, let's rename this back to just .env. Inside this file, we are going to replace the empty string with the just copied API key. So we have the Pinecone API key. So now this is going to work. So the API key is going to be picked from the .env file. Right, so since we have the instance of Pinecone created, we can access the create index function like this, and inside this function it accepts an object. So what do you want to create? What index do we want to create? So what are the parameters for the index that we want to create? So we have a name. We provide a name, which is going to be the index name that we are going to pass down over here, the target index. Okay. And once we have the index name, we create a dimension. Remember, when we were going through the steps in creating, on how Pinecone works, we have the embed data, create an index, and then ingest. So we are creating the index, and remember, I said we need a dimension over here. We need a dimension. So that's what we are going to provide for this side over here. So the dimension is going to be 1020. So meaning we want to create 1020 dimensions for this project. Okay. And we have the spec, which is going to be an object with a serverless object again, and we have a cloud. The cloud is going to be AWS. And then you're going to have the region. The region is US East 1. Then we have wait utility, util ready to be true. And you're going to have suppress conflict to be true. So we have the create index if necessary function created. Let's move back to the bootstrap, handle bootstrapping function and import that. So create index if necessary, we have that imported. And the next step we are going to do is to check if the index that we created has a vector. So we create a constant named has vectors. And this is going to check if, the index is having a vectors. If there is a vector, we are going to return, okay? Because there is no need to create a vector. Else, we are going to create a vector, load the document, create an index for the document, ingest the document, and prepare them for searching, right? So let's go ahead and, create a function that is going to check if the Pinecone index has a vector. So back to the pinecone.typescript file, we are going to have that function here. So what we are doing here is to, this is an async function and we provide the index name as an argument. So we create a target index variable, which is just going to, be the pinecone.index, provide the index name, get the target index, create a variable for the start, await for the target index dot describe index stats. So if the start contains a total record count and the record count are greater than 0, meaning there is, an index for the, meaning there is a vector for the index. So what do? We return a Boolean. So true or false, and then we check, and then we throw an error, checking the Pinecone index. We give this a save. Back here, we call the function. So you're going to have Pinecone index has vectors function provided target index. And this is going to return a Boolean, true or false, as we saw here, true or false. And we are going to check if has vectors. If there is a vector, we just return from this function. We don't do anything at all. We don't load, go through the whole process again. When I talk about going through the whole process, this is what I actually mean. This process of embedding the data, creating index, ingesting, and preparing it for search. We just have to return. So I'm going to have that here. Oops. Where is it? Okay, so this here, we are going to have, first we log to the console that, the Pinecone index already exists and has vectors in it. So we return early. Let's call next response from, next server. Let's scroll all the way up here and import that next response from next server. Beautiful. So what do we do if we do not have any vectors? Well, we load the document and their metadata, prepare them, ingest them, and create index for them. Like go through the whole process that I talked about earlier in the video. So console.log, loading document and metadata. We have that. So the document can be found inside this doc folder. So when you check the starter file, you can see we have all the documents that we are going to use for the semantic search. So these are cases, you can open them. I do not have a PDF viewer in my code editor, but if you do have, you'll be able to see the cases and everything that there is to know. So I'll get back to this db.json file, which is a very important file as far as this project is concerned. I'll get back to this and explain everything for you guys. So let's create a document path. Let's create a variable to hold the document path. So docs path equals path.resolve process.cwd. Remember, we have to import path first. So, let's go ahead and do that. So the way up here, we import path. So we have process.cwd. There's a function. And what we are doing here is to, get the path to the document, right? So we have here, and the document file path starts with docs / and then we create a variable for a loader, right? So we are going to use a tool called Langchain. So what Langchain does is a loader tool that converts data from various sources and formats them into a standard document object. So it's a popular tool, for formatting PDFs and, any other documents. So we are going to have that imported over here, the directory loader from Langchain, document loader fx directory. Scroll the way down here, create a new instance for the directory loader. So we have directory loader, which is going to accept the doc path as an argument and an object. So the object is going to specify the, extension, the file extension for the document that we want to use. In our case, it's a PDF file, so we are going to use a PDF. So we have PDF, and we have the file path, type to be string. Then we create a new PDF loader. With the file path. So let's go ahead and import the PDF loader. We are getting that also from the Langchain, document loaders fx PDF. So we have the loader created, variable created. The next thing we are going to do is to create a variable for the document itself. So document equals await loader.load. And we want to check for some conditions over here. What do we want to check? So we want to check if the document.length is equal to 0. If that is the case, we say no PDF document found in the docs directory to prevent, the code from running into any feature error, and return this here, this error message with the status 400, right? And next, we are going to create a metadata, variable to read the metadata of the document. So metadata equals await read metadata. Metadata. So we are yet to create this read metadata function. So let's scroll all the way up here and create that function, right? So a constant read metadata is an async function, right? And you're going to have the promise document metadata and inside here we are going to have our try catch block. Awesome. All right, so let's import promise as fx from fx. So let's import that here. And we are going to know the uses of this in a second. So over here, we are going to create a file path, like what we did over here. So what we did here was a doc path. Over here, we are going to create a file path. So the file path is going to be like this. So path.resolve, we just get the file path for each of the, documents. As I mentioned, this file is going to be very important in this, application. So the db.json file contains the JSON objects of all the documents that we have over here with their metadata, right? So the file name, we have us versus nizon.pdf. So for this file, and this file is being titled over here as United States versus Nizon. You have the plain TIFF, United States, defendant, date, topic, and outcome. So we do this for all the files that we have in the docs, okay? We do this for every single file. So that's what we are actually loading over here, the file for the metadata. And then we use this. So we create this variable here, data, to read the file, okay, in the UTF-8, mode. Then we pass the data, create a variable and store it inside, and return the parsed document. Return the parsed document, and we are going to console.log any error that we may get as long as this function is concerned. So we have that's created. All right, so let's import the type for this document. Okay, so let's import that over here. Remember, we've already created the type inside the types folder. So we have the types for the document, and this is the same metadata that we have in the db.json file. Beautiful. So we can now continue on with the rest of the functions. So we read the metadata, then we check if the document is valid, right? So we create a variable here, valid document. We filter through all the documents and check if the document is valid using the isValid function, which we are yet to create. So we scroll all the way up here, just right above the handle bootstrapping function. We paste that here. So what this is doing here is to check if there is no content, and if the content is not equal to string, we return false. If that's not the case, we trim the content and make sure we trim the length of the document, because the Voyage API has a maximum token limit. So we are going to talk about Voyage in a second. Okay. So back to this side here, we have the valid document function created. And next over here, we are going to loop through all the valid documents, load the metadata for each file. So we just loop through all the documents, create a variable named file metadata. We find, where the meta file name is equal to the name of the document that we are looping. If that is the case, we create a new metadata object and, append all these properties to that object. And that's what we are doing here. To count the valid document, we log the valid document length, and then we split the document into smaller chunks for the AI to be able to index the file correctly or convert them into the vector embeddings correctly. So this is the function that is going to let me just add a comment here that is going to say split into smaller chunks. So we have this function here, recursive character text splitter. So all we are doing here is to split the document into chunks. So we are getting this recursive character text splitter from Langchain. If you guess it, you are right. Langchain. So we scroll the way down here, continue with the rest of the code, and we are going to process the batches. So process in smaller batches. So we chunk the data, we split into smaller chunks, and then we process each chunk. So we are going to have the number of batch sizes that we want to process, which is going to be 5, and can be changed based on your preference. So it's a constant that contains the batch size. We loop through all the chunked data using the for loop. We loop through all the data. Inside this for loop, you're going to do a couple of processing over here. So the first thing you're going to do here is to have this code. And what this code is doing here is to split, the data into the batch sizes and log, the batch size as it begins to process. So we log, so let's say processing 5 batches, at a time, everything is going to be logged into the console. You're going to get what I'm trying to say. So after we are done and we are just about testing the app, we are going to see this in the console and it's going to make much sense. So you're going to have this code here is valid batch. Remember, we created this is valid function, which is going to check if, there is any invalid document and skip the filtering or the processing of that batch. So after we are done with that, we are going to have this piece of code over here. So what this code is doing here is to process each valid document split by trimming the page content, right? And flatten the metadata and assigning a unique identifier to each document, and then create a new array of documents with the updated metadata and trimmed page content. So we are going to, have this function created or imported and also have this unique identifier. So let's scroll all the way up here and create the function for the flatten metadata. So up here, right, just right here, paste this function here, which is going to flatten the metadata. And we are also going to import the unique identifier from this package here, UUID. So we have that, we have that over here. So the next thing we are going to do is to create the embeddings using Voyage AI. So we create a try-catch, try-catch block inside here. We generate embeddings using the Voyage Embeddings. I believe at this point, we all know what an embedding is. So embedding is basically converting the document into the, the vector form, this form over here. This, vector form, numerical representation of the said document. So we create the embeddings using the Voyage AI. Voyage AI. So we are going to have this piece of code over here. So what we are trying to do here is to create a new instance of Voyage AI, Voyage Embedding, and provide an API key, the input type, and the model name. So this is going to help us create the embeddings. So let's go ahead and import the Voyage Embeddings, and then get our Voyage API key. So we scroll the way up here and have that imported. Awesome. So let's go get our Voyage API key. And on this dashboard page, you can create a new API key. So I'll create a new one. Name it legal semantic search API key Voyage. Create a key. If you don't have an account with Voyage, make sure you create one before you be able to create an API key. So I'll copy this key here, move back to my local .env file, paste the Voyage API key over here. So we have the key over here. So after we are done creating the Voyage embeddings, we are going to create the page content and the embeddings. So we are going to have this over here. Paste this code here. We have the page content. We have the embedding from Voyage Embeddings.embed document. So what all this is doing here is to prepare the document for it to be converted into vectors. So after we are done with that, we create the actual vectors. So how do we create the vectors? We create a constant over here named vectors casted batch.map, and then this is going to create the vectors for us. So we have the ID, we have the values, and we have the metadata for each batch that we processed. And the next thing we are going to do is to offset it to Pinecone. Without doing this, it's just creating vectors without any uses. So once we have it offsetted to Pinecone, we can now make inferences from the document. So let's have that piece of code over here. We are going to create a new instance of Pinecone, and we have the batch upset function. So let's go ahead and create this instance and then create this batch upset function. So we first import the Pinecone over here, and then we create the batch upset function. So we are going to have that function here, paste it over here. So what we are doing is to just batch upsetting all the vectors into Pinecone database, and that is going to have for us just that. So if there is an error in processing the vectors or doing the vectors embedding, we are going to have this error message over here. And if anything happens during the process of the document, during the bootstrap procedure, and anything that has to do with connection timeout, we are going to have that error message over here. So return that error message over here. So that will be it for the error. So let's add at any. So we have completed the bootstrap.ts file. We can now move to the next part of this application. So right now what we want to do is to, let's call the handle bootstrapping function here. Handle bootstrapping. All right. And we are being able to, when the application loads, we are going to call the bootstrap, post request, which is going to lead to calling the ingest, API endpoint. The ingest API endpoint is going to call the handle bootstrapping. Then we have all the processing that I just explained, right? So that is how the embeddings and everything works. So next, let's work on the search route. So this is going to be the route that is going to help us in making search or queries to the Pinecone, database, right? So let's have all these imported at the top here. So let's have all these imported. We import Next response, we import Pinecone, Voyage Embedding, and Pinecone store. So the search is going to be an async function. So we have export async function, post, we have request. The type is going to be a request, and then we create a constant to distract the query from await request.json. Distract the query from request object, and we check if the query doesn't exist. We throw this error here, query is required, else we perform this in this try catch block here. So what do we want to do? We want to initialize the Pinecone client. So we've done this a couple of times in the bootstrap services bootstrap file. So we just create a new instance of Pinecone and also initialize the Voyage embedding with the correct type of queries. So we create this here, Voyage embedding, provide the Voyage API key, the input type query, and the model name is going to be Voyage Law2, right? And then we initialize the Pinecone vector store. So let's initialize that and log the query to the console. Okay. So we have that over here. So you're going to have this variable here named retrieve. Based on the query, we are going to, get a couple of response and from the vector store, the Pinecone vector store. And we want to, just return maximum of 20 output, right? And right from, getting the queries results retrieved and stored in this variable, we are going to filter and ensure the result set is unique. So we filter by using the metadata ID. So you're going to have that here. We filter through the results and make sure we filter on the metadata ID. So the results are supposed to be unique. And we return, next response.json. and you're going to have this error, over here, error message if anything goes wrong. So we are done with the search. I think it's time to, work on the homepage of the application to make sure we are, getting something inserted inside our Pinecone database and see, what we have in the console, right? So inside the page.tsx, the home page, we don't have anything here. So let's start importing everything that we will need in this component. So first thing first, let's create an interface for the search results. Okay. Search results. And we are going to have the metadata document, metadata, and we have the content to be string. So we are getting this metadata from the document types that we created over here. These types, document types that we created. So we are getting that over here. And so let's create a use effect here, which is going to check and bootstrap the index. Remember, we created the bootstrap function inside this component, the bootstrap.ts file over here, to go through the entire process. So we check if we do have an index. If that is the case, we don't do any bootstrapping. Else, we bootstrap and go through the whole process all over again by creating an index, creating a vector embedding, and those kind of processes. So you're going to have use effect and use state imported over here. And we are going to create the use effect, over here. So we are going to create this function here named check and bootstrap index, right? Check and bootstrap index. So let's go ahead and create that function first and, come back here to continue the rest of the code. So this is going to be the function. So the function is going to be check and bootstrap index. An async function. So we first set the is bootstrapping state. We have to create a state for is bootstrapping and also a state for is index ready. So let's go ahead and create those states inside here. So we have this state. We set the is bootstrapping. Oops. Set is bootstrapping. This is going to be an argument. So is bootstrapping a boolean. Have a void over here. Then we have set index ready as well. It's going to be very similar to what we just created. So I'll just paste that over here. Awesome. And we are going to have our function. Okay, so let's start writing, the components of the function. So the first thing we want to do is to set the bootstrap index. We set that state to true, which is going to be important when we are rendering a spinner at the front end. Then we await run bootstrapping. So run bootstrap procedure. And this function, we have to create it just right now. So this function, run bootstrap procedure, is going to call, create a post request to the API bootstrap endpoint we have here, which is going to initiate the bootstrapping. So we have that post request. So we can await for that over here. And if the process is done, we want to set there is bootstrapping to false, and also set there is index ready to true, meaning we have an index ready. So let's move back here and call the check and bootstrap index function. So check and bootstrap index function. We're going to pass in the set is bootstrapping state and the set is index ready state with no dependency, right? So we have an error here that says the argument to create index had validation error. So property name must not be blank. So back here at .env, let's add, the Pinecone index. So let's make this port 3001 because we are running on port 3001, and let's change, let's write a Pinecone index over here. So we can make it, legal semantic app, right? Legal semantic app. And when we save this, we should be able to, bootstrap successfully, ingest all the documents and create the vector embedding. So let's give this a save. So let's wait till there is a call to the bootstrap endpoint. Or we can, so let's wait, let's wait. Or perhaps we can move to the localhost port 3001, refresh the page, which is going to trigger the bootstrap, hopefully. So you have the bootstrap endpoint triggered, running the bootstrap procedure against Pinecone. We created, so we are going through the, the chunking, the processing of the batches, generating embedding, upsetting the batches to the vectors, right? So where there is an invalid file, we don't continue with the batching and embedding. We throw an error, but still continue with the, processing. Beautiful. So let's wait for a while the application is processing the batch and generating the embeddings for the 5 chunks. So while we wait for this process to be done, let's go ahead and continue on with the rest of the application. So let's create a function to handle the search, right? Let's create a function to handle the search. We are going to create that function right over here. Okay. So I'll copy everything and explain it line by line. Copy this and paste it over here. So what we are doing here is, sending a request to the API search endpoint, okay, with a body as the query. So whatever you want to search will be passed as a body to this endpoint. And we already know how the search works when we were creating the endpoint for the search in the route.ts file. So I will not go over that again. And if the response is not okay, we throw an error. If there is a result, we store it in the set result state and set the searching state to false. So let's create those states. So you're going to have those states over here. Awesome. So we have successfully, completed the bootstrapping and ingesting the data inside the Pinecone database. So everything is ready and we will be able to, make search when the interface is ready. So we have the handle search function created, and we are going to create this array here that is going to contain suggested searches, right? And this array contains suggested searches, okay, from the documents that we have available. So back here, processing legal documents. So we have processing legal documents. We are going to, check for the is bootstrapping state. We want to run this only if, the bootstrapping state is in the process of, bootstrapping. And then we show the spinner. So once the spinner is done, we want to check if the index is ready and the bootstrapping has stopped. So we are going to have, this state to check that. So once we have the index ready and not is bootstrapping, we want to show this form to help the user, perform some search. So you're going to have this div here as the parent div for this whole, document. And we are going to have this, the header, legal document search, use natural language to explore legal documents, and the search form. So let's import the search form. We have that in the component. So let's just import it, which is basically going to display the search form for us. So we have the onSearch, as the function that is going to trigger the handle search for us. And if we are searching, we want to show the user this spinner to, enhance the user experience, to tell them there is something going on the screen. And if there is a result, we want to show the, a div here, which is basically going to, have the total number of results that we had based on the query. And we are going to have this clear result function here that is going to get rid of the search query if the user wants to perform, any further searches. So you're going to have that function over here. Give it a save. So the final piece of the puzzle is going to be after, we have a search result. So we want to loop through all the results and display the results in a beautiful card. So you're going to have that. Import card. Import card. Import card content from component. And also have this state, okay? Set selected document. So let's go ahead and create that state. Because you have that, just over here. So we are going to have that just over here. Beautiful. What is left? We have to create a function to sanitize the string. Okay. So let's import the function to sanitize string. We already have this created in the lib. We have that created here, sanitize string. So I'll just have to call it. And that will be it for the page.tsx. So let's go ahead and check what we have in localhost port 3001. So boom, we have legal document search, use natural language to explore legal documents and precedents. So we can search for any cases. So let's try cases involving guns. Hit on this button. We are searching through the document. And boom, we have these results. This is amazing. So let's check the Pinecone dashboard to see what we have at the edge. And we have the index that we named. So remember, in the .env file, I named this index legal semantic app. So that is what we have over here. So remember, we programmed this application to create an index if we do not have any. And that's what we have here. We have the dimensions. When we move back to the Pinecone bootstrapping, Pinecone services Pinecone, we can see we have the dimension over here. 1024. We have the serverless cloud AWS. We have US East 1. So everything is working beautiful and amazing. To share this app with your friends or add it to your portfolio, make sure to host it first. This app can be extremely useful for lawyers and law students to learn about cases, especially if you expand the knowledge base. This brings us to the end of these tutorials. Thank you for staying to the end and keep on building amazing things. See you in the next one.